Hi, Steve here at the SJCOE Fab Lab, and we're going to be doing a little bit of work with computer science. Now, computer science uh, is the way that, or the study of using computers to solve problems. So we're not actually going to do any coding today, but we are still doing computer science. Students are going to be doing computer science to better understand the climate. CO2 and climate are a theme throughout NGSS chemistry classes. So let's get started on this topic that's really important and powerful learning for the students, and it's also going to give them some computer science skills. Now, California computer science has 5 categories in its standards. Algorithms and programming, the coding we tend to think of for computer science. Computer systems, because all computation occurs on a physical system, we should understand the systems that do this computing. Networks and the internet. You're probably watching this on the giant network of networks that we call the internet. Networks make our computers so much more powerful. And then data and analysis. That's going to be the category that our standard that we're dealing with is going to come from. We are constantly gathering data, and that data allows us to make decisions. Some of those decisions are really important. So students being able to look at data and understand data and use computation to help them with dealing with large amounts of data is a really important skill for their future, for all of our futures. And of course, that was 4. Number 5 is impacts of computing, because we want the students to use these skills that they're getting to make things that help people, to solve problems for everyone. All right, let's look at the specific standard that we're dealing with. It is 912 DA11. Refine computational models to better represent the relationships among different elements of data collected from a phenomenon or process. So we're going to look at models. We're going to use some tools for creating computer models. Here's the interesting thing: they are no code computer modeling tools. Let's look at SageModeler and CalAdapt. So we can create visualizations of a model of our phenomena using SageModeler, and students can do this with no coding. Let's click on Launch SageModeler. I'm going to create a new document. Let's go with something simple. Let's say when the sun is out, it causes the temperature to increase. So I'm going to create a new image. I'm going to type sun and temperature. There we go. Well, the sun is going to affect the temperature, and I can make an arrow to show that relationship. How does the sun affect the temperature? Well, I'm going to double click on this arrow. I'm going to say, you know what? There's an increase. Whenever there's an increase in the amount of sun, I'm going to say there is a lot. So this isn't lots of math. It's more conceptual. There's a lot of increase in temperature. Okay, let's say, well, we've got our SageModeler data. Notice this chart is showing us. Now let's gather data. I'm going to hit record. And now, as I adjust, notice how it's gathering points. I'm going to go ahead and stop recording, but I want to make a graph. I'm going to say I want to see the sun versus temperature. Oh, hey, that's kind of the type of relationship we said we expected. Now, it's really straightforward with only two items in the model. We can have a much more complicated model to represent something like climate. Let's look at CalAdapt. So CalAdapt has lots of charts using data and models. So there's lots of data from the past and models predicting the future. Let's look at, explore all the data tools. I'm going to look at Snowpack. Oh, wow. So notice we have data going back to 1960, but looking forward years, decades into the future. I'm going to go ahead and hit play and see what happens over time. Ooh, not as much snow. So I'm going to pause right there. Now, students can take a snapshot of this using the snip and sketch tool in order to be able to use the I2 method to label what they see, um, what they're seeing means, and interpret what it's telling. You know, make a caption explaining the meaning of this chart. It's a way for them to start understanding the charts that they're looking at. They can also very easily click on download. If they go to chart, scroll down, there's other charts that they can look at, and they can click on download the chart. So screenshots, downloads, lots of ways for students to get those charts so that they can work with them. Let's look at a model that is specific for what we're looking at. This albedo model is something that the students can work on and improve is kind of the key. Remember, our goal is for students to be able to improve models. So let's see what it's telling us. Well, more ice causes more energy to be reflected into space. However, there is more energy retained with an increase in the amount of CO2 and the amount of energy from the sun, and that changes the temperature of the Earth itself, melts more ice. We could improve this model. Maybe we could add in a few more images, drag them in. Maybe it should include methane. It's a greenhouse gas. Students can look at this model, gather data, but they can also improve the model and then use the I2 method to interpret what the chart is telling them. Again, taking a screenshot of their chart, labeling it, saying what those items mean, and then making a caption. All right. This is a really straightforward lesson, but it's powerful in the way that it allows students to use some great tools to be able to understand data. I hope the kids have a lot of fun working with this. Thank you for joining us.